Thank you.
Okay. But yeah, just a little bit about me. My name is Meaghan FitzGerald. I'm at AvaLabs. I work as a DevRel engineer. I've been here for a year. I work really closely with our platform engineering team as well. They're the engineers responsible for the creation, maintenance, and feature application of Avalanche-Go, which, if you are familiar with Ethereum and Geth, which is the engine that runs that you would run on any node to like have an RPC node or to validate Ethereum, you use that software to do so. It runs the consensus engine, and it also runs the execution environment for what would be, like applications that you're running on and hitting your node on, right? So that's Geth is to Ethereum, as Avalanche-Go is to the Avalanche blockchain. I do want to get a gauge of the participants in this room because I'm going to start pretty high level and then go deeper and deeper as the presentation goes on. I think we have about 2 hours allotted. I don't plan to use all 2 hours to give a presentation, so I'm very happy to have you guys interact with me, come off mute, drop questions in the chat. But just a show of hands, how many people have developed on the Avalanche blockchain before? Either in Solidity or run a node or done anything? Do you guys know how to raise your hands in Google Meet? Oh, maybe it's just we have a good amount of newbies. Okay, so Annie's in there. Annie's done that. You can also heart react. That's okay. Okay, wait. Okay, then a better question is probably how many people here have ever written any Solidity code before? Okay, there's Michelle. There's Okoli. Okay, great. A good amount of you guys. Okay, so Avalanche has multiple chains in its network. That's kind of why we call it a network of networks. But one of our most popular chains is the C chain. That's the chain that if you go to buy the AVAX token, AVAX token, we kind of don't really agree on the pronunciation, but if you go to buy that token, it exists on the C chain. And the C chain is basically another implementation of Ethereum. It runs different consensus, which is why it's so quick, but the Solidity development experience is pretty much identical because we keep that fork of Ethereum up to date with Ethereum as it applies upgrades to the network. But I'm going to jump into things now. So Avalanche, what is Avalanche? If you haven't heard of it before, Avalanche is an open source platform for launching dApps, and you can also launch your own blockchains. We call it a network of networks. And the primary architectural difference between us and other ecosystems is that every application, every blockchain launched within our network is not rolling up or rolling down to any of the other blockchains that exist there. It's certainly possible, but the primary architecture of Avalanche is that we have a bunch of horizontal blockchains that are all at the same layer. So no one blockchain on our network is providing security to the other blockchains. They're kind of all experiencing a network effect as validators come online to validate new blockchains. They're also validating our primary network. So as new blockchains are launched, the strength of the network gets a lot stronger. And one of the most novel things about Avalanche, and honestly the reason that it was created about 4 years ago, was that a group of researchers at Cornell created a new consensus mechanism, which allows blocks to be finalized at like a way faster rate than that of traditional proof of stake. I'll get into this on a couple more slides, but it's one of the fastest Solidity smart contract platform in the industry as measured by time to finality. So that means when blocks are finalized and when transactions are virtually irreversible. And what this does is that each subnet or each blockchain provides its creator with an entire environment for developing the application without the creator having to worry about traffic on other chains. So like a big issue that I faced when I was starting out in blockchain was that when I would build applications and then deploy them on mainnet, the traffic from other applications made my users' experience really horrible because sometimes they'd be paying fees of like 5 cents, and then sometimes they'd be paying fees of $5. And that's just really inconsistent experience for my users. A lot of the times, if they had like liquidity locked in the platform and they wanted to move it or they wanted to add more, having to pay a fee of $5 feels awful when this is supposed to be a step up from the traditional financial applications that they're used to working with, right? It's also just inconsistent, especially if the network is surging because of somebody else's application that you for instance don't really care about. It just is really frustrating for the feeling that you have like a lack of control over your execution environment, right? So what subnets do and what Avalanche allows people to do is launch a blockchain that works exactly the same as the blockchains they're used to building on, but are completely unique to the application that that person wants to run. So you have your own block space, you validate your own network, and you have historical information that you're syncing with your nodes and your validator set, but you're not having to sync that of another network, which you don't really care about the data. So you can also really manage very well your validator costs, and all these other variables that otherwise were out of your control are now completely in your control. Back on the topic of finality, I did explain it a little bit earlier, but finality is something that we haven't really been actively discussing in the industry for about 2 to 3 years now, because as L2s have come into the realm of things and have provided like a really fast user experience, the one really big downside of L2s is that to achieve finality on the L1, which is essentially what gives each transaction the security that it deserves, it can take anywhere from a few days to a few weeks, depending on what L1 the L2 decides to roll down to. And that's just because of the speed that transactions are being finalized by the consensus engines that they're employing, right? So technically, if a transaction isn't final, it could be reversed by either being thrown off the stack, like thrown out of the mempool because it didn't fit in a block or conflicted with another transaction. Or it can be thrown, basically not finalized and delayed in finalization because there was a hard fork in the network, or one of the leading blockchains, like on a proof of stake basis, was winning, right? So that block kind of gets thrown off the heap and then has to be like put back in the queue. But in Avalanche, this isn't a problem because all of our blocks are finalized in 2 or less seconds because of how fast the consensus works. I have a lot of slides for this, so if people are really interested in how our consensus is different than that of other chains, I'm happy to go through it. But if you guys would rather move on so that we can get to like the code with me session, I'm happy to do that too. So does anybody raise your hand if you want me to go into detail about Avalanche's consensus? All right, Destiny. Okay, all right. I feel like there's enough interest here. So I'll go more in depth into it. So basically, the way that networking works in Avalanche is we have a group of nodes, and our consensus is probabilistic. So what that means is that we do this subquerying algorithm. So if n is equal to all the networks or all the participants in a network, the node that is proposing the block is going to query a subset of the validators of the network. So if n is equal to 100 and k is equal to 20, when I go to propose a block, I'm going to ask 20 of the validators, like whether or not they prefer the block. If 15 out of 20 of them say, yes, I prefer this block, meaning that that is the next block that they would like to add to the chain, then I'm going to count my confidence threshold once, meaning like I'm going to keep count of how many times in a row I get that answer. And I have to do that 20 times in a row before a block is considered final. So I'm going to click this little demo link, which is a demo that was made by one of the founding engineers of Avalanche. The network is 20 by 20, so this is actually a 400 node network. So it's, 400 node network. The sample size we're using here is k equals 10. Like you can toggle this in this demo if you prefer, but it's just what's set by default. And the alpha is going to be 8 out of 10, just for sake. You can find these parameters for our actual network in Avalanche Go. They don't change very often because this is kind of after doing a bunch of simulations. The safety versus liveness balance is best when the parameters are set. Oh wait, you guys can't see this. I'm only showing. Let me switch to this, share this tab instead. Okay. So we have a network of 400 nodes. A node is going to propose a block, and it's going to ask 10 nodes in this sum sample, do you prefer this block? If 8 of them say yes, it's going to count 1. And the confidence threshold for our network is 20. So it has to get 20 yeses in a row before the block is considered final. But it'll query 20 times. And if at any point in time it doesn't get that 8 out of 10 threshold, the confidence counter goes back to 0. And I'm just going to go. You guys are going to see basically on the graph on the bottom of the screen that it starts off a little slow, but very quickly the network kind of begins to have this like positive feedback loop where if I'm already at the 5th round of querying a subsample and I've gotten 5 yeses in a row, the chances that the next group of nodes that I ask for their preference is going to be yes is higher because you've already queried 5 groups and they've said yes. So you kind of, this is where like Avalanche gets its name because it starts off like a snowflake, you know, rolling down a mountain. But then as it gains momentum, it speeds up very, very quickly. So this is really good and really scalable because basically what it means is that as you add nodes to the network, it won't slow down the time that it takes to finalize blocks. Basically, like if you think about how proof of stake 66% threshold networks work, kind of like Ethereum and other like traditional proof of stake networks, those networks are based on the notion that when someone proposes a block, in order for it to be final, 66% of the network stake has to have signed a transaction to say, yes, this is final, and I consider this final. So if you just need 66 out of 100 nodes to sign a transaction, if your network is 100 nodes, it'll perform that at a certain speed every time. But if you double that and you have a network of now 200 nodes, to get 66 times 2, which is 130 something. I'm not good at that kind of basic arithmetic. But if you need now double the amount of nodes to have signed a transaction, it's going to take that much longer for your blocks to be finalized. Versus in Avalanche, we just need to query a subsample of the nodes, of the network's nodes, and get that answer to be the same 20 times in a row for a block to be final. And probabilistically, this is how our consensus works. And the chances that that block won't be finalized are near 0, even in networks up to 100,000 nodes. So does that make sense to anybody? Does anybody have any questions about that? I know it's very theoretical and like, you know, I'm not the best at multivariable calculus either. So if anybody has any questions on how that works, feel free to drop it in the chat. Or feel free to come off mute because we have plenty of time to do so. I'm gonna just check the chat real quick. Okay, so there's a couple questions in the chat. If it goes to 0, transaction gets declined. No, so your transaction doesn't get declined. Do you mean like, okay, so you were saying in that instance where the confidence threshold goes to 0 because a subsample did not say, yes, I prefer this block. Yeah, so the transaction doesn't get declined. It's just that that block is no longer the preferred block by the network to be added to the blockchain. Because what's actually happening here is that this process is occurring in parallel with a lot of other nodes. So all at the same time, there are a bunch of nodes proposing blocks. And we can't add all the blocks at the same time. So what happens is that that node proposes that block to a subsample. And so long as everybody says yes, or like most people say yes, then it's like, we're going to do that again. But if they don't prefer that, it's because there's another block currently being preferred over those. So the transaction doesn't get declined. It doesn't get thrown away. It just gets delayed. But it gets delayed by a very, very small like millisecond margin. And then eventually it is, because while this is all happening in like an async environment, it's a very, very quick process of like peer-to-peer communication. Does that answer your question? Great. All right, I'm going to move on. I'll get back to this. Yeah, so avalanche consensus is really quick. On the C chain, it's about 2 seconds, but on any of the independent blockchains that have been deployed by like blockchain developers, it's near 0. It's very quick, especially if your network is really small or if you don't have a lot of competing transactions or blocks. Like the chances that, you know, you propose a block that someone is going to decline are super low if you're the only one on your network proposing blocks. If your network has 100,000 transactions being proposed at once, it's going to be a little bit slower than if it only has 100 transactions being proposed at once, right? And then, of course, this is just a visual to compare it to the finality of other chains. There are different purposes for different chains. I'm not going to deny that. So I think that the security that you gain from a network larger that takes longer amounts of time to accomplish finality might be beneficial somewhere. But I also believe there are a lot of instances in our industry where applications do not need to be sharing state and be sharing block space with other applications that don't interact with them in person, interface with them at all. So you'll hear me in the demo especially refer to the Avalanche primary network. These are the 3 main blockchains that are completely public and permissionless on Avalanche, that are owned by the community and validated by a decentralized network of validators. They have the fastest time to finality. They're secure. They're very scalable, like I said, up to like a very, very high number of nodes. And they remain performant under heavy loads. Like even back when inscriptions was happening in December and January, and a lot of EVM compatible blockchains were seeing an insane number of like mint events being emitted by those who were taking inscriptions from Bitcoin and putting them on other EVM chains. Our chain remained performant and remained, very reactive to that. We saw some transaction fees spike. But what I mean by that is that it went from pennies to like $1. It didn't really go that high. It's also energy efficient and lightweight compared to other networks. Like you can run a node that validates the Avalanche network on a lot of very, very average computers, and smaller amounts of memory and bandwidth and disk space are required to actually validate our network. You can state sync the Avalanche network with a validator, meaning that you are only syncing like the latest block and then the root of the Merkle tree that will return all the information from previous blocks, but you're not actually like saving every single block's information on your node. And to sync our testnet, Fuji, which is the one I've synced most recently, maybe like a day or 2 ago, I spun up an entirely new node to sync the entire network. It only took like a day and a half, versus I know that there's a lot of other chains that if you want to validate and sync the whole network, it'll take you up to 2 weeks to validate all of that, or to sync all of that information and get your node's memory up to time equals now, basically, to catch up to what the network has already produced. This is a rough number. I'm sure there's well over 1,000 dApps on the Avalanche blockchain by now. And then we have 3 chains, but the most important one that we'll be interacting with today is the C chain. The C chain is that copy of the Ethereum virtual machine. It's a fork of Go Ethereum, and it is where all of our dApp smart contracts and other infrastructure exists. This is if you don't want to run your own blockchain and you just want to deploy an application that is super quick and provides like a really nice user experience, you would do it there. The P chain manages our validators in the Avalanche network. It's kind of like a registry just for like when validators come online, when they're rewarded by the staking mechanisms employed by the subnets that they validate. And it keeps kind of that information public to enable messages to be sent between blockchains as well. We have a really cool protocol here that I'll get to later that makes it so that in order to transact information or send tokens to and from blockchains within our network, you don't need to deploy a bridge based on a third party. You don't need to trust a third party, meaning like an independent developer or layer 0 or a bridge that is deployed by a group of developers in order to bridge funds from chain to chain, you only have to trust the P chain, which is already validated by our entire network. So that's pretty sick, but I'll get to that. Are there any questions? I'm gonna check the chat. Doesn't look like it. Feel free at any point to come off mute to challenge these ideas, to, you know, give me your 2 cents. I'm always interested in hearing people's impressions, because I was introduced to this network quite a long time ago, and I've been building on it for a very long time. So I love to hear new ideas and opinions from everybody. So like I said, the C chain is a fork of the EVM, and it's, you know, solidity-based smart contract environment. It's faster, and it's cheaper. So another thing I like to put into perspective is the actual compute power of the network itself. So for reference, the Ethereum network is processing around 100 billion gas per day, and that's kind of the cap that it's been, because like everyone complains that transactions just keep getting more expensive and more expensive. But what's happened is that the demand for block space on Ethereum has reached its like theoretical cap at what it can safely process while still like providing a competitive environment for transactions to be sent. So at this point, the supply in Ethereum has kind of reached its limit when it comes to compute and when it comes to like execution. But the demand keeps going up still, because Ethereum network is like really, really popular with developers, and it's like a very well secured network by the validators that validate it, right? On Avalanche, what we have is we have that environment in the C chain, but then any of our other chains that have been launched themselves, sometimes people call them subnets, but you can just think of them as independent layer 1 blockchains. Anytime someone launches that and begins to use that, they've basically taken that max theoretical cap of block space and added it to the network. So if our network was just the C chain, it would have that same cap as Ethereum, 100 billion gas. But because there's nearly 100 different chains that the Avalanche public network is currently validating, we have like a theoretical cap of 100 times 100. And what we're actually using every day is nearly 1.2 trillion gas. We're like consistently over 900 billion gas use per day, which is about 9 times the size of Ethereum. And as people like deploy more and more blockchains on our network and begin to use those like to deploy their applications, to transact, to send and receive funds and everything like that, this number will just continue to grow, because the theoretical space that gets added every single time a blockchain gets added is that much more. Does anybody have any questions on that? It's a really cool concept. Like basically the execution like supply, or the supply for like compute and things you need to run any application or to run like programs basically on a machine is uncapped, because you can always deploy another blockchain to do so. And then you can use our interoperability protocol that I'm going to talk about later to send and receive funds like in a very permissionless way. So that's why I'm so bullish on this network, because I just believe that our engineers have focused on the same thing for a long time, which is how do we ensure that developers always have optionality when it comes to the environment that they run their applications on, while also maintaining like the notion of interoperability and interchangeability of like assets and value, right? Because like if you're just deploying another blockchain, but it can't communicate with any of the other blockchains around it, then you're kind of just like, why wouldn't you just build on a server privately owned by you in your AWS account? You know what I mean? But I think that we preserve the values of our ecosystem and give optionality for solutions that engineers can actually use. So I talk about subnets a lot. I also refer to them usually just as blockchains, because I think the word subnet can be kind of confusing, but it's a network like that you as a developer can design entirely yourself. It can be private, which means that you can host it with your own set of trusted nodes, like a proof of authority blockchain. If you're a institution, if you're a bank, if you have to abide by like geographical laws and regulations because you handle proprietary information, or you're just a large organization that has a lot of rules and regulations it has to keep in mind when building technology, subnets are a really great way to do that while also utilizing blockchain technology. But they can also be completely permissionless and basically essentially an entirely new L1 that anyone can spin up a validator and validate. So depending on what your goal is as like an ecosystem creator, as an application developer, you can kind of toggle these options when designing the network. And everything is composable and customizable, right? So we've kind of like given you the options, tried to include as many different iterations as possible, and then give you the tools to make those decisions yourself as a developer. A subnet can run one or many blockchains. We don't need to get into what the implications of that are, but if you want to run 5 validators and you want to create a new blockchain every single time you have a new idea, then you can feel free to do that. That's totally up to you. And you can define your execution logic, which means you can use a fork of the EVM, or you can use a fork of the SVM, or you can use something that is compatible with like SUI-based programs, or like the Aptos blockchain, or WASM, CosmWASM, like whatever virtual machine you want to deploy and validate with Avalanche validators, you can do that. You can design your staking mechanism if you want people to stake to your network in order to validate. It's just like the possibilities are endless. I've been talking about this for the majority of the presentation, but what are the benefits of subnets? And that's just, again, like an environment completely under your control, or a new permissionless blockchain that is going to serve a different purpose than those that are currently out there, right? Higher transactions per second, near to zero transaction costs. And if you're designing a subnet actually with like applications that already have a high number of users, you can set it up in a way that makes it essentially gasless, using a relayer to use the gas token that you've created when you created your network to be relayed for every transaction. Now, this doesn't mean that people can use your network for free, but what it means is that every single time that they emit a transaction, you as the owner can supplement them with as much gas as they need. And then you can charge them using like USDC if that's what you prefer, or using a different token if you want them to pay for transactions denominated in a different token. They're independent, so subnet A is clearly very congested right now with transactions, but subnet B won't see any influence from that. And then this was a fun slide created by one of my coworkers, but basically to demonstrate the customizability, you can design a road, you can design a canal, you can design train infrastructure. Like you can design a chain meant for a completely different purpose than another chain. Like one of our most simplest virtual machines that we had a developer create is called timestamp VM. And all the virtual machine is doing is requesting the time from like the international time standard endpoint and returning it as a value in each block. So that VM's whole purpose is just to keep the time. And you can use that as for whatever you need in your application. Do you know what I mean? So our president, John Wu, believes very much so that customizable demands of subnets are what Fortune 500 companies are using to launch their own blockchains. And this has been pretty apparent in the past year because we worked with a lot of traditional financial institutions that want to use blockchain as a way to basically take a bunch of industrial inefficiencies and make them more efficient, meaning like there was a application built, a POC back in November with JP Morgan. And they basically were able to demonstrate that 1,000 or hundreds of steps that would need to be taken by portfolio managers at their banks could be reduced to about 2 to 3 when they based the technology on a blockchain-based system. And this system was not only with them, but with other banking partners that they were able to include in their conglomerate to basically demonstrate that like you can interoperate in a permissionless way while still doing things according to the law, which was really cool. So this is like a nice little visualization of the network. I think I took this screenshot though like a year ago, so it's definitely bigger than this now, but like you can visualize the Avalanche network as sort of this like growing snowflake, and as people deploy their own blockchains, the snowflake just gets more complex. And I think I'm going to stop here because I believe that I would like to get into the demonstration for the next 20 minutes on how to deploy a blockchain and then how to send a message from your blockchain to another one in a very simple and permissionless way. Does anybody have any questions before I do that? All right. So as much as I love the sound of my own voice, here is a link to the instructions of the demonstration that I'm going to share my screen and share with you all. So if you want to follow along with me, you can go ahead. If anyone is actually very, very interested in being the person to do this locally on their machine, and you just want me to instruct you and you're going to share your screen, I'd also be down to do that. But I understand that maybe people might not be comfortable with that. All right. I am going to share this tab. So this is the Avalanche Starter Kit. This is a new repository that we created about a month and a half ago to make it really easy for developers to get started. And one of the biggest issues that we found when making tutorials was that not everybody's environment was the same. Some people are running a Mac, some people are running PC, some people are running Linux, some people are running a Unix-based system. And we just wanted to make sure that everybody could experience and understand like really from end to end go through a tutorial without getting caught up in like a system difference between the system that I develop in, which is primarily Mac, and the systems that other people develop in. So a great way to do that, actually, if you haven't done so yet, is to use GitHub Codespaces. Assuming you guys are all at the starter kit. Oh, there's a question. No, they're not, Destiny. So you can definitely use this. Do you have a GitHub account, and are you logged in and can view the link that I sent in the chat? I'm gonna assume yes. But can everybody see my screen? And you guys see this big green button here that says code? You're gonna click that. Oh, let's see. Nice. Okay, gonna click code. And then it says local, and this is when you usually get cloned to your local machine to like clone a repository. You don't actually need to do that with GitHub anymore. You can use a code space, which will set up an environment in your browser that already has the dependencies all there. So I'm just gonna go here. I'm gonna make sure I'm on the main branch, and I'm gonna click code spaces, and this big green button that says create code space on main. If you don't see this big green button, you can also click this plus right here that says create code space on main. And then that should open up a new tab that looks like this. It looks like VS Code. And it might take a little time, but this is going to set up a remote connection with the code space, and then it's going to run some code that we've defined to make sure that your environment is has all the dependencies installed to do the tutorial that I'm going to show you. I really hope that this only takes 2 minutes to set up, but sometimes this can take a little bit of time. So it should say building code space. In the meantime, I think I'm going to describe what we are going to do. So I'm going to share back the tab that has my repository here. And then from here, I'm going to click the source folder, SRC. And then I'm going to do the first tutorial, which is send and receive. And what we're going to do in this tutorial, the instructions are the markdown document. is we are going to send and receive and verify a message between a subnet and the C chain, which is the primary network that Avalanche runs. This is all going to be done on what's called a local network or a DevNet. This is essentially your own private testnet. So like if you've done things on Gurley or Sepolia or a testnet for any other EVM chain, that is still like publicly verified and validated by nodes. What a DevNet is a copy of that, but on your machine local. And all of that is just personal to you. So it's like a brand new, fresh testnet that you control. So my screen now has updated itself. Your code space should look like this. It'll say your username, and then it'll say the directory that we're in. And then this might open up, and it says it's running post create command. Don't worry about that. It's just getting the config to match. But we're going to read through the instructions. Is everybody who wants to be here at this point? Nice. Again, if you guys have any issues or like need me to slow down, just let me know. Okay, so again, we're going to go to the source folder, and then we're going to go to the 0 send and receive folder, and we're going to click instructions. I don't like the way this looks, so I'm going to right click. And if you right click, you can scroll down and it should say open preview. It looks like on a Mac, you can also do Shift Command V. So maybe on PC, you can do Shift Control V, but it should format the instructions a little bit nicer instead of having to view like the markdown code. Okay, so we're going to do it on a local network. First thing to know is that when we're creating our subnet, it's going to airdrop all of the native tokens of the chain that we create to an address, but it's stored locally, so it should be very easy for you to work with. And all the commands that we have made do this intentionally and natively. It's still running this post create command, which is fine with me. Okay. So the first thing that we're going to do is deploy a subnet. So to do that, we're going to type avalanche in our terminal, subnet, create my subnet. And everybody can name it my subnet. That'll make it easier for you to follow along. This is the name. This is the Avalanche CLI is called by just calling the word Avalanche. And then we have our subnet commands. We're going to create the configuration of our subnet, and then we're going to name it. So naming it my subnet. So it'll say choose your virtual machine. By default, we provide an EVM fork. So we're going to just hit enter and select the EVM fork. We're going to choose to use the latest released version. So I'm just going to hit enter again. And then it'll say, would you like to enable Teleporter on your VM? Teleporter is the Ethereum virtual machine-based interoperability protocol that I mentioned earlier. That's what's going to make it really, really easy for us to communicate with other blockchains in a permissionless way. So I'm going to hit yes. And it says, would you like to run an AWM relayer? This is just the relayer that is running in the background to take all of your cross-chain transactions and send them to other chains. So I'm going to say yes. It's going to install it. Now it's going to ask you for a chain ID. Because we're just doing this on a local network, it can be whatever integer you want it to be. I usually just do 868686. My token symbol, this can be whatever you want as well. I think I'll just do toke. And then it'll say, how do you like to set the fees? This also really doesn't matter for the purposes of this demonstration. So I'm going to do the first option. And then it says, how would you like to distribute the funds? I'm going to select the second option to airdrop 1 million tokens to the default address. This is just going to send all of our subnet's native token, all of our blockchain's native token, to the private key here that is already established in our local environment, and make it easy for us to deploy and call functions in the future. Would you like to add a precompile to modify the EVM? I didn't really talk about precompiles. This is just another feature of subnets, but I'm not going to get into it today, so you can select no. And then it should say successfully created subnet configuration. So let's see. So now what we're going to do is we're going to call this function to get the blockchain ID of the subnet that we just created. So I'm going to copy this, or I'm just going to type it out actually. Avalanche subnet scribe. And then I named my subnet. If you named your subnet something differently, then you would put the name there. I'm going to hit enter. And let's see. The main funded account is this one. Yeah, and this is the private key here. Let me make sure that private key matches. Okay, it does. 562 matches this 562. This is formatted kind of weird because my terminal, like I zoomed into my terminal, but hopefully this looks better on your computer. And let's see, I was looking for the blockchain ID of my subnet, right? So this is the chain ID that I made, but that's not the blockchain ID. Maybe it's just this. This looked different last time I did it. Different information. You can find the blockchain ID of your subnet with this command. Destination blockchain ID. Yeah, no, that's different. This is weird. Let me just look into my repertoire real quick. I could have sworn it was delivered in a different way. Let me check one of my other tutorials. I should print the blockchain ID to the console. Am I missing this? Oh, maybe it's because I didn't deploy it. That might be it. All right, we're going to deploy the subnet first, and then we're going to get the blockchain ID. So to deploy your subnet, you're just going to do avalanche subnet deploy, and then the name of your subnet. And we're going to choose local network. You can ignore that. It's going to boot the network. You can wait until healthy. Which basically what it's doing is just spinning up a network of nodes locally on your machine. And that network of nodes is going to then create that blockchain with the configuration that we set in the avalanche subnet create step. It's deploying our contracts that are necessary to send and receive messages for us, which is great. So it deployed it to the C chain, which is the primary network of Avalanche. And then it also deployed it to your subnet. It deployed the relayer that we talked about earlier. And then I'm going to just zoom out to see if it formats a bit better. If this is too small, I can post this information there. This should all be the same for you, but there might be a couple of values different. But so it spun up 5 nodes. Those 5 nodes are now running on your machine. This is the endpoint for each of them. There's also a Codespace endpoint. I wonder if this will do anything. Connected to the forwarded port, but there's no page because it's just running in the background. Let me see. Can I redo the steps of creating a subnet? So I'm not going to go through the whole steps, but in order to do so, all you do is avalanche subnet create. And then actually I can send a link that might tell you exactly which steps to create. Yeah, so if you, let me get if you follow the instructions here under the section called subnet configuration, that will be identical to what I just did. And Annie just said we're also going to share the recording tomorrow, which is great. I deployed my subnet on local network. Did you deploy it on a DevNet by accident? Because if so, I can help you stop that. Okay, so it's showing my token is toke, my chain ID. This is the funded address with the tokens that I created as my subnet's native token. And then the blockchain ID should now be returned by this avalanche subnet describe my subnet. So there we are. It's all under the details of the subnet. Why is it formatted so bizarrely though? Yeah, it's just because of the sizing in the terminal. That's fine. All right, so the local network blockchain ID in hex format will be returned by avalanche subnet describe and then the name of your subnet. So if you type that command into your terminal and hit enter, under details, you should see this local network blockchain ID, and that's where you can copy the blockchain ID of your subnet. I'm going to go back to the instructions for the send and receive. And the first thing we're going to do is in the send and receive folder, there's a sender contract called sender on C chain. I'm going to click that to open it. And then I'm going to go down to the destination blockchain ID. And I'm going to replace that in the first line. So I replaced this line 20 here, with the destination blockchain ID of the subnet that I just created, which again, you can get that with the avalanche subnet describe command, and then the name of your subnet. So I'm going to save that. So the sender contract, we're going to deploy it on our local network C chain, which again is just like a copy of the testnet. And then we're going to deploy another contract on the blockchain that we just created. It'll be this contract. Everything should be the same otherwise. So now we're going to deploy our contracts with these commands here. So I'm just going to copy this line. I'll post it in the chat in case you guys aren't following along with the instructions. Make sure that it's all one line and that there's no like forced enters because I just posted it in the Google Meets chat. I'm back here, going to my terminal. And then in my terminal, I'm going to paste this. And what this command is doing is it's using Foundry, which is kind of similar to Hard Hat if you've used it before. It like does a similar thing. Basically, it is a SDK that helps people deploy contracts to Ethereum-based blockchains. So I'm using this forge command to create a new smart contract on my local network C chain. It's going to sign the transaction with the private key that we funded with C chain box. And it's going to take my receive contract, or sorry, the sender contract, and deploy the sender contract onto my local C chain. Great. So it just deployed that to my local C chain network. You should see the success. So we did that. And we're going to now deploy the receiver contract on our subnet. So I'm going to copy this below, and I will paste it into the chat for you guys. And this is doing essentially the same thing. It's just deploying that receiver contract for the message onto the subnet. So we have a contract on C chain, which is a separate blockchain, and then we have a contract on the blockchain that we just created. And it was also successful. Now we can send a message. You can find the sender contract address, which is the first contract that we deployed, the sender on C chain. Here, it'll say deployed to. We'll take that value. What? No selection of copy. We'll take this value, copy, and we'll place that in this command here. So I'm going to actually copy the whole command. I'm going to paste it in my terminal. I'm then going to copy the address that the sender contract was deployed to, and I'm going to post it here where it says sender contract address. So I'm going to delete sender contract address. I'll paste that there. And then we need the address of the receiver contract, which is the second contract that we deployed on our subnet. So it's here in this line that says deployed to. I believe this should be, like, these addresses should be identical. So long as your subnet was named my subnet, these will be the same. So I'll post the total command into our chat. So if you guys are having trouble formatting it, you can just post this command, hopefully. And then we can write whatever we want. So I'm going to write build her rocks. And let me take this and copy it for you so that you can see it. So this command, the cast command, is also a Foundry command. What it's going to do is it's going to look at this address, the first address I put, for a function called send message. And send message is in the smart contract that we deployed, which is here. It's the only function in this contract, very simple Solidity contract. It's going to have this be the first input in the function, which is the destination address that our protocol will deliver our message to. And then it's going to look for another argument that's called message, which is just this string that I wrote builder rocks on. And it's going to send that message cross-chain by implementing this teleporter interface that I talk about. So teleporter on Avalanche is used, it's like a very complex protocol that uses the validator sets of each blockchain to send and then confirm messages. Ton of cryptography involved. We have a lot of information about this on our documentation website, which is docs.avox.network. And we also have it on our YouTube, which is just called like the Avalanche blockchain. Or if you just search for Avalanche blockchain, you'll find our YouTube channel. I would love to get into the weeds of that, but I'm almost at time. I'm actually already at time and I'm late for another pretty important presentation, but I'm going to be quick here. So I'm going to take this command and we're going to send this message across chain. So the blockchain ID you find with Avalanche subnet describe, and then the name of your blockchain. And then you would scroll down to the details section. There's two blockchain IDs. One's in one format, one's in another format. The hex format is the one that you want. Okay, so I'm going to hit enter. So you'll see the transaction object returned. If you have ever used Foundry or Hardhat or even Truffle, like this should look pretty similar to you. It's basically a formatted JSON of the transaction that was just emitted by your signing key. So again, this private key environment variable is just the private key of that one public private key pair that we are all using in this demo. which you should never use in production because it probably is owned by hundreds of thousands of people by now. But it was a success, and this is the transaction hash. And if we had a block explorer, we could go confirm, but we literally just spun up this network ourselves, so we don't have a block explorer for that, which is fine because it's really cool. We're running 4 blockchains locally on each of our machines right now. But in order to confirm that the message was in fact delivered, we would call this final function from Foundry. So again, we're going to need the receiver contract address, which we have from the output earlier when we deployed the receiver contract. But I'm going to take this last verifying message receipt function, or sorry, command. I'm going to put it in my terminal, and I'm going to replace the receiver contract address. Oh, what did I delete? My subnet. I'm going to replace the receiver contract address with the receiver contract address, which is this number here. Should be the same again. I'll paste this all there for you in case you guys had different messages that you want to confirm. And let's see if it delivered or if this is not going to work for me live, but I'm pretty sure it will. Yep, it did. So it confirmed, like by calling in the RPC of our subnet blockchain, that it's received this message from an entirely different blockchain. And we didn't need to deploy a bridge, and we didn't need to trust a third party who doesn't care about our messages in order to do so. We did that by just trusting the network itself and the nodes that are deployed. Does anybody have any questions about this? Was anybody able to do it? Or is stuck maybe and wants some help figuring it out? Nice. We got 2 thumbs ups. Valentina, congrats. Okay, cool. All right, it looks like a good amount of people actually were able to do it. These tutorials are all obviously available on GitHub for you guys to use, and each of them can be run in a GitHub Codespace. If you want to do it locally on your machine, you're absolutely more than welcome to do so. You would just have to install like Foundry and then maybe, I don't know, like a couple of other Git dependencies that we have installed for you here. Any of that stuff can be found in the dev container folder, I believe, or maybe it's VS Code. When we ran the post command, where was that? Let's see. It was like git config. Yeah, so post command create ran this one command. If you want to do this locally on your machine instead of doing it in a GitHub Codespace, when you clone the repo, just run this command locally so that you can recursively install all the dependencies of the repository. And then go ahead and you can change the ports if you want to change the ports, but this depcontainer.json is basically how you initialize your local environment to do so. But I really like GitHub Codespaces because I think it makes it really easy. This was our simplest tutorial we have. We have 8 other tutorials, and then there's a couple in the works for more complex contract deployments and invoking functions and using the teleporter registry. But this is a really in-depth, like developer, like beginner jumping off point that we've tried to engineer to make sure that everybody has a way to, on their own, discover how our protocol works. Again, if you guys are really interested, I highly recommend checking out the Avalanche Academy, which is another platform that we built specifically to help people in like a Khan Academy or like a Udemy like style platform learn about our network and learn about the complexities, because it is a super complex network. We have a lot going on. Our engineers are heavily into the research behind everything that we're doing. And we're constantly looking for ways to improve the network, make it super scalable, make it really fast, make it super safe, and basically just enable like development and improvements, because we all kind of know, especially those of us who have been in the industry for a while, that there's still a lot of work to be done before we get mass adoption, because of how difficult it currently is to use blockchain technology and to feel safe using it, right? So if you guys are interested, I highly recommend checking out the Avalanche Academy. If you're more of a reader, docs.avox.network, also a great place. And if you want to look directly at the code, anything in GitHub under AvaLabs is owned by the developers from AvaLabs, obviously, and that includes our consensus engine that runs the whole network, avalanche-cli. That's what you run if you run a validator, and any of the other info that we produce. But I think I'm at the end of my time here. So if anybody has any questions, it's your last chance. Okay, in that case, thank you all for joining. I appreciate the active participation. And if you guys have any questions for me or just want to chat about Avalanche, you can find me on Twitter and on Telegram. Let me get I have a little website with all the ways to contact me. I just need to figure out what I named it. I think it's a bento. Some of us have bentos here. I just don't remember what the end that I chose. Oh yeah, okay. And there may be dependencies to locally download. That's the thing about GitHub Codespaces, which is so great, is that all of the machines are basically the exact copy of each other. It's just like a virtual machine hypervisor type of thing. But I don't know what dependencies you have downloaded versus like what I have downloaded, right? Because I know that I've used Foundry and I've installed it. But yeah. Oh yeah, okay, you have Linux. This should work fine on your Linux machine. What is the task to be done? So we deployed it to Subnet during the workshop, and we also used the Avalanche CLI to do so. We also deployed and utilized our interoperability protocol called Teleporter. I believe if you've done this with me, then you've accomplished the task. If you haven't done this, then I challenge you to deploy a subnet, run it locally on your machine, and send a few transactions using whatever protocol you want. It could be hard hat, it could be Foundry. It could even be Remix. We have a ton of tutorials on our docs that are Remix based if you're interested in that. So I recommend, but that is my time. Thank you, Annie, so much for organizing and getting everyone hyped up around this. And I'll see you guys around. If anybody's going to EthCC in July, let me know. We can meet up. Okay, Annie, I think I'm gonna hop. Goodbye, everybody.